In this video, we are going to be talking about fraction, decimals, and ratio. And one of the things you always come across that will help to solve this question most of the time is what is generally regarded to as BODMAS, or in some quarters, they regard it as PEMDAS. And this generally refers to the order of operation that you can carry out when you are solving questions on this. BODMAS refers to brackets of division, multiplication, addition, and subtraction. And PEMDAS also refers to parentheses. So you can see parentheses and brackets, they're actually the same thing. Then we have exponents. This is the format for exponent. Any number raised to another value, okay? Then you have multiplication, division, addition, and subtraction. And if you are observant, you notice that in BODMAS, of down to multiplication, they are talking about products, while addition and subtraction are just talking about sum, okay? Then here we have multiplication and division, still talking about products, addition and subtraction, okay? I think this should be appropriately tagged as minus, okay? So in this other case, we have it that exponent is standing out. So in all cases, always do your bracket or parentheses first. Then I will advise just go for exponents if there is an exponential expression in your question, and then follow through with the product and then the additions. That is going to help you to get to the root of your problem and solve it as appropriate. Okay, so that being said, on BODMAS and PEMDAS, when you are working with this, particularly with decimals, if we say we have a number, let's say 3, 4, 5, 6, 7 dot 8, 9, 1, 2, okay? Generally, whenever you are trying to solve, you can take this decimal place and you can move it to either the left, okay, or you can move it to the right. And this is going to enhance whatever we are going to solve. Now, look at this, because this is the means by which we express in standard notations. If you choose to move the decimal point towards the left some number of times, let's say you move it 1, 2, 3, 4, so you are taking it to this particular location, you are going to have 3 points, all the whole number that you have initially, 4, 5, 6, 7, 8, 9, 1, 2. But now, how many times have you moved this decimal place to the left? 1, 2, 3, 4. So you say this is times 10 to the power of 4, okay? But in this particular case, if for the same number you're actually moving the decimal place towards the right, let's say you are coming like this, 1, 2, 3, okay? So that number will translate to 3, 4, 5, 6, 7. Now you move it behind 1.2, but because you are moving towards the right, then you are moving how many places? 1, 2, 3. That will be times 10 raised to the power minus 3 in this particular case. Okay, so this will help you to simplify questions that you are solving and find the simplest expression that you can pick from the set of options you are going to be given, or just pick to get your answer right. And then, having known this, the other thing is, if you are working on fractions, ratios, you have some numbers, maybe 7x over 5 is equal to some other unknowns, maybe 3. Of course, you can multiply both sides by the denominator to just simplify it. So if you are saying multiply by 5, this will knock out this. And then since 7 is here, you can also multiply by 1 over 7. So whatever you do to this left hand side, of course, you also need to do to the right hand side. So you can also, this is like 3 over 1, then multiply by 1 over 7, multiply by 5. And then this 7 can cut out this 7, and x will just be 3 multiplied by 5, which is 15 over 7. Just know that you can knock out the coefficient of your variables by either multiplying with the denominator or dividing with the numerator. That will seriously enhance you to solve this question. And having this basic foundational knowledge, I think we can go ahead and lay our hands on some questions, and you see how those can really help you in solving questions when you face them in your exam. So just get your pen, get your writing materials, get your books. Let's work together. As we normally say, is as you do that, that you get to build proficiency in solving this question, and then you can face it in the exams and it will just be a walkover. So let's head over and solve some questions together. In this question, okay, we have this to simplify, and as a rule of thumb, it will be good for you to convert to proper fractions, in which you are not having whole number beside fractions, you just have ordinary fractions. So if you have to write out this expression, that means we are going to have something like 3 over 4. Off is the same as multiplication, so we have of 4 over 9 divided by, if you want to take 9 whole number 1 over 2 to a proper fraction, we say 9 multiplied by 2, that's 18, plus 1, we have it as 19 over 2. Then, of course, they are even putting all of this in brackets. We have to divide by. Again, here we have this improper fraction to connect to convert it to a proper fraction. 1 multiplied by 19 is 19. 19 plus 5, that is 24 over 19. So this is good and quite interesting. And because, look at all these expressions, ideally we are to find out what is in the bracket first and then get to operate on this later one. So to find out the one in brackets, we are having multiplication and division, which is the same thing. And if you want to simplify division, you turn it to multiplication and reverse the order of the fraction. Initially 19 over 2, it will turn to 2 over 19. So we are going to have 3 over 4 times 4 over 9 multiplied by 2 over 19. So that is what is going to be in the bracket, and then we have divided by 24 over 19, which we'll get to in a gimmick. Now we can simplify this. 4 and 4 are going to cancel out. 3 here, 1, 3 here, that's going to be 3. So we have 2 over, because I'm seeing 19 here and I'm seeing 19 here, I want to retain that 19. I'll say 3 times 19, that's what is in the bracket. Then multiply by, since we are multiplying, changing this division to multiplication sign, we need to reverse this as 19 over 24. And you can see why I deliberately left this 19 instead of multiplying it up, because 19 and 19 can cancel out. 2 here 1, 2 here is 12. So what I'm having left is 1 over 3 multiplied by 1 over 12. And 3 times 12 is nothing but 36. So 1 over 36 here is going to be the solution to this question. Okay, quite an interesting question here. If P ratio Q is given as this and Q ratio R is given as this, we have to find P ratio Q ratio R. Students, you can try some methods to try and solve this, but I'm seeing that Q seems to be the one that will combine these two expressions together. And because of that, I would like to flatten out based on Q. Okay, so when I have P ratio Q as 2 over 3 ratio 5 over 6, I can take that as P over Q is 2 over 3 divided by 5 over 6. Okay, so if I'm to cross multiply this, I can just have 5 over 6P is the same as 2 over 3Q. But remember, I'm saying Q is my point of interest here. So I can say inherently P itself is going to be 2 over 3Q multiplied by 6 over 5. And from where we are coming from, what I just did is that I'm multiplying this with 6 over 5 so that 6 can cancel 6, 5 can cancel 5. And then the same thing I'm saying multiply by 6 over 5 here. That is what is giving me this expression here. I just want you to know that, students, okay? So if that is what I'm doing in this case, on the other case, I will just say Q ratio R is going to be Q over R is equal to 3 over 4 divided by 1 over 2. And here again, I want to make Q my point of interest. So I'll just make R the source of the formula. I can just say I want to cross multiply to have 3 over 4R is equal to 1 over 2Q, such that from here to, I will just repeat to say R now is going to be 4 over 3 multiplied by 1 over 2Q. So now in this case, look at where I'm going. I've been able to find an expression for P, able to find an expression for R. So if I want to express this out now, P ratio Q ratio R, I can say what I'm having is 2 over 3 Q multiplied by 6 over 5 ratio Q itself as a whole number, ratio R now is 4 over 3 multiplied by 1 over 2 Q. And you can see Q is common to all of them, so I can divide all through by Q. So here I just need to find a means of taking out the denominators. Now I have 3 and 5, that is 15 here. I have 3 and 2, that is 6. So 3 is common to the 2. I can take just 1 3. So I want to multiply all of this by 1 3, and then I have 5. Okay, also multiply by 5. I have 2, also multiply by 2. So in that particular case, student, look at this. That means in the first case, I'm going to knock out 3 and 5. 3 and 5 are out. Remaining 2. 2 times 2 times 6 will be 4 times 6, right? And 4 times 6 is nothing but 24. So this is going to give me 24 ratio. Here, I'm multiplying by 3, 5, and 2. And that I got to be 15 times 2. That is 30, okay? And here, I have 4 times 1, all right, as the numerator. But at the denominator, 3 and 2 will cut out 3 and 2. So I have 4, 1, and 5, which is 20. And for all of these 3, I can see that I can still break them down, dividing by 2. 24 over 2 is 12. 30 over 2 is 15. 20 over 2 is 10. And that is interesting, is expressed as option A. So, students, I particularly just try to make you the point of interest there because it's what I can find in P ratio Q and Q ratio R. So I baseline to make P a subject of the formula reflecting Q in the first expression, and then R subject of the formula also reflecting Q in the second expression. And then if I flatten them out, just like I explained at the beginning, you want to knock out denominators, then you multiply by those denominators, and each sequence, I'm doing that, multiplying each sequence by this product of the denominators, and I'm going to find 24, 30, 20, which 2 is common to them. Then I'm going to find my baseline ratio as 12, ratio 15, ratio 10. All right. Okay, this is good. And the product of 0.21 and 0.34 in standard form. Okay, so there is quite a number of ways you can choose to solve this. All right, but I think I want to do 0.21 is going to be the same as 21 times 10 raised to power. Now we are moving the decimal 1 to 2 places, minus 2. Okay, so this we are multiplying by 0.34 is going to be 34 again times 10 raised to power minus 2. Okay, now a cheat code, students. 21 and 34. If I'm saying 34 times just 2, that's going to give me 68. If I'm adding, let's say I'm adding 0, okay, 0 at the back, then that will be 680. But because it's 1, that is 714. So this is a quick tip when you don't have time and you are trying to solve your question. This is 714, and you are multiplying by 10 raised to power minus 2, and also multiplying by 10 raised to power minus 2. This and this. But then with the laws of indices, you know that if you are multiplying two different expressions having the same base number but different powers, you can just take one of those bases and then add the powers together. So we have plus minus 2. Don't throw away this negative sign. If you do, you will miss out. So this is 714 multiplied by 10 raised to power minus 2 minus 2. So it's nothing but 714 times 10 raised to power now minus 4. Now this is where it gets interesting. Look at what they did here. We only have 7.14. So here I'm having it as 714 times 10 raised to power minus 4. But then it's like just saying 714.0, and I need to now move my decimal point 1 2. I'm moving it in 2 places to this particular point just after the 7, and that will mean that I have 7.14 times 10 raised to power. Because I move it 2 decimal points to the left hand side, that's times 10 raised to power 2, and then this 10 raised to power minus 4. And just like we did there, 2 plus minus 4 will be 2 minus 4, which will be minus 2. So this is going to give us nothing but 7.14 times 10 raised to power minus 2. And looking at the option, we can see that A is going to be the solution in this particular case. Okay, this is quite an interesting one. Let's just first convert to proper fractions. 3 whole number 2 over 3 will become 3 times 3, that is 9, plus 2, we have 11 over 3, times 5 over 6, times 2 over 3. And we are dividing all of this with 11 over 15, times 3 over 4, times 2 over 27. So students, you may be tempted to try and be solving this piece by piece, then combine your answer later. But this is what I want to do. I want to flatten out everything. So for the numerator, I have 11 over 3 times 5 over 6 times 2 over 3. Then since this is division, now if I want to express it, I'm going to say times. I will now need to reverse each and every one of these. So I have 15 over 11 times 4 over 3 instead of 3 over 4. And in the third case, yes, you guessed right, it returns 27 over 2. So now I can just choose to cut 11. We'll cut 11. Interesting. Okay, we have this is 27, and we have 3 times 3 is 9 times 3, that's 27. So all of those cut out this 27. What else? We have 4 and 2, 2 here 1, 2 in 4, that is 2. Okay, whereas 2 here 1, 2 in 6, that is 3, 3 here 1, 3 in 15, that is 5. So we have just these numerators left, 5, 2 and 5. So that will give us nothing but 5 times 2, which is 10, 10 times 5, and that's going to be 50. So 50 here is going to be the solution to this question. Okay, this is looking quite interesting. If mn and q are in the ratio 5, ratio 4, ratio 3, we have to find 2m minus q over m. Again, just like the question we treated, I want us to flatten this out. N is going to be the common term to both m and q here, standing in the middle. So I can say m over n, we are expressing that as 5 over 3, whereas we are saying n over q is being expressed as 4 over 3. So I can just also make m like the sort of the formula. So m is going to be 5 over 4n, while q, if I want to make it the sort of the formula, I can just tend to cross multiply. Taking q up, I'm going to have q to be 3 over 4. And you can try and convert and confirm that to see that that is actually what is going to happen. So when we're now talking about 2n minus q over m, it's going to be 2. N is still going to retain itself, okay, minus q. Q is now 3 over 4n over m. M is going to be 5 over 4n. And of course, here you can even see that n is common in both the numerator and denominator, and we are left with 2 minus 3 over 4 divided by 5 over 4. So n had been effectively knocked out. So 2 itself, if you are saying over 4, m2 will be like 8 over 4. That's 2 minus 3 over 4. We are dividing by 5 over 4. So this is quite interesting now, and we can try and solve with this. This is supposed to be 4, that's not 5. Okay, so That means up here 8 over 4 minus 3 over 4. It's deliberate that I'm just taking this out because I know that will just give me 5 over 4. Then with this division, we still have it as 5 over 4. A number divided itself is nothing but 1. So looking at the options, you can see here option C is 1. Just like the question we did initially, just flatten it out, and once you do that, you'll be able to just substitute and solve your question as appropriate. Okay, in this particular question, I don't think we need to do this together. You can do it yourself. Attempt this and let me know in the comment section what solution you are able to come up with. If you have been following all along, this should be a walkover. So all the best, get yourself trained and practice with this question. Okay, this is looking quite simple. 21 over 9 to 3 significant figures. 9 in 21, we are going to have 2, but 9 times 2 is 18. So 21 minus that 18 is going to give us 3 over 9. Oh, that means this is nothing but 2, 3 can cut 9 to give us 3. So we have 1 over 3. 1 over 3, if you press with your calculator, is nothing but 0.333333 and on like that. So we have to get this to 3 significant figures. That means the number of figures that we want to see should be 1, 2, 3. So we're having 2.3. Now, before we take the last digit, we need to look at the numbers after it. Now, the particular number after it, the digit after it. Now, it is 3. Numbers from 0 to 4, we round down to 0, and it's not going to have effect on the number preceding it. But numbers from 5 to 9, we'll take this and round it up to 1, and then add to the previous digit. In this case, since it is 3, it's falling between 0 and 4, so it's not going to have effect. So we have just 0.33, and option D will be the solution in this case. Okay, yeah, we have 3 girls sharing apples in ratio 5:3:2. The highest share is 40 apples. We have to find the smallest share. I don't think you need to sweat yourself so much on this. What's the highest share here? It is 5. Look at what I'm going to do. I'm going to say 5 is corresponding to 40, okay, in the ratio that have been shared, and then we want to find what 2 which correspond to, because 2 is regarded as the smallest share. So here, all I just need to do is to try and cross multiply. So I have 5x is equal to 2 times 40, and if I divide both sides by 5, this 5 will knock out. 5 can go in 48. 2 times 8 is 16. So x is nothing but 16. So that's a very quick method for you to solve this. And because time is of the essence in your exam, you want to do as fast as possible and move on. If you have some other means, you can just drop it in the comments to see how best we can solve it if we are coming across questions like this in subsequent times. But I think C, 16, is the right answer. Okay, look at this. You have to evaluate this correct to 1 decimal place, and then this is where you need to move your decimal point to standard notation that will help us to solve this. So in the first case, 1.25, if I want to move the decimal place and make just 125 whole number, I'm going to have 125 multiplied by 10 raised to power. I'm moving the decimal place 2 places to the right, so I have -2, okay, then times, in the second case, I have 0.025. I'm moving it 1, 2, 3 to after 5, so I have 25 times 10 raised to power -3. I'm dividing with, here I'm moving 2 places, 1, 2, so I'm having 5 times 10 raised to power -2, and already I'm seeing -2 in the numerator and denominator, so that will cut out 5 here, 1, 5 in 125, that is 25. 25 times 25 is 625, times we only have 10 to the power of -3, okay. And like I said, if I want to now reverse this, to the power of -3 means that I can actually move with this 625 that is having its decimal here, let's say 0.0. When I want to move it 3 places, I mean 1, 2, 3. So it will need to become nothing but 0.025. 625. And then look at the question they're asking us to one decimal place, and just like I explained before, 2 is not up to 5, so it will be rounded down to 0 and should not have effect on this. So approximately my answer is nothing but 0.6, and that is option A in this particular question. Okay, again, I think students, you should also lay your hand on this. If you have been following along, you just need to move this decimal place, and then you can multiply and then revert it and see what you can get as your answer. But notice what was written. This is 8.6. okay, the other ones are just whole numbers, so be careful when you are trying to pick your option. But I think you should be able to do this all the very best. I can also ask you to just lay your hand on this, but let's give it a shot so that you can also see more practices from our hand in this particular case. So on the numerator, if I want to simplify this, I'll need to move my decimal place into, okay, let me just write this out first. 0.00045 times 2.50. I'm dividing with 0.00009. You don't want to miss the number of digits, so you need to be consistent with what you are doing. So here I'm moving 1, 2, 3, 4, 5. Okay, so I'm having 45 times 10 raised to power minus 5. Okay, times, if I'm just moving this a singular point here, I'm having 250 times 10 raised to power minus 2. Okay, then here 1, 2, 3, 4, 5 again, so I have 9 as the remaining digit times 10 raised to power minus 5 times here 0.5. here I'm just moving once, 5 times 10 raised to power minus 1. See, you can see the consistency with what we are trying to do, so that there's no room for mistake. So 10 raised to power minus 5 will definitely cut out. 9 here 1, 9 in 45, that is 5. That 5 and this 5 will still knock themselves out. So we have, look at this, please, you need to be careful trying to solve question here. So we have 250 multiplied by 10 raised to power minus 2. But now this is division divided by 10 raised to power minus 1. So inherently this is nothing but 250 multiplied by 10 raised to power minus 2. This division will translate to minus, okay, and then we have this minus 1. That's where you need to be careful so that you don't get to do unnecessary mistakes. So we have 250 times 10 raised to power minus 2. Minus times minus will become plus 1. So definitely this is just going to be 250 times 10 raised to power minus 1. Of course, this is saying that we just move the decimal place back one step just to this point. So that's going to give us nothing but 25. And looking at the option B is that correct option that we need to pick in this particular case. Just notice the consistency and you'll be good and fine. You will know that you're on the right track and you get to answer straight and fine. Okay, with what we have just done, I think you can do this yourself. Lay your hand on it and you can leave your comments in the comment section if there is any problem trying to solve this. But it should be a walkover. If you are consistent, you get it right. Okay, do we need to solve this? I think it's almost the same thing. Students, get to lay your hands on it. Just be consistent, move the decimal places, solve it as much as you can, and then revert back with the decimal places, and you'll be good and fine. So again, do it yourself. Practice will build perfection in you. All right? So I think you need to take note that the consistency of this warrants that you pay attention to how you will be able to master this as much as possible. You can see how they are repeating this question again and again. So just make sure that you lay your hands on it. You are not glossing over it. Please get that pen, get that paper, practice this, solve it by yourself, and let's see what comes out of it. All right? Wish you all the very best. do this yourself also. Okay, we've solved the question like this initially, but I think in that particular case you're only having multiplication and division. But yes, since we are having subtraction, I think it should be worth our consideration. And remember the rule of thumb, we said we have to start with the bracket. So if you want to write this out, we're having 1 minus 1 over 7 times, like I said, always express proper fractions first and foremost. So this is an improper fraction. As proper fraction, this will be 3 times 2 is 6, 6 plus 1, that will be 7 over 2. Okay, then divided by 3 over 4. So you need to carry out the operation on the one that is in bracket first. So if you want to do that in this case, we are going to have 1 minus, of course, this 7 is cutting each other. So we have it as 1 over 2 divided by 3 over 4. Students, the very silly mistake to do here is to carry out the operation on 1 minus 1 over 2. No, this is now a division. And if you remember BODMAS, we need to also do division first before we do addition and subtraction. So in this case, it's going to be 1 minus 1 over 2 divided by 3 over 4 will become multiplied by 4 over 3. Okay, so we have 1 minus, of course, here 2 can cut 4, that will be 2. So we have 1 minus 2 over 3. And 1 itself is just like 3 over 3 minus 2 over 3 will give you nothing but 1 over 3. And option B is going to be your solution. Don't make the mistake here to think that, yes, I've first done the bracket, then let me subtract from 1. No, the order, either you are considering PEMDAS or BODMAS, is that first and foremost, carry out multiplication or division if you are finding them in the expression. Then what we will do last is addition or subtraction. So if you are consistent with that, 1 over 3 will be your solution. Okay, this type of question again. Okay, let me just lay my hand on this so that again I will reiterate the core concepts to your hearing. 0.0028213, we are dividing by 0.634, and I'm saying that you move your decimal place a number of times: 1, 2, 3, 4, 5, 6, and 7. So this is 28213 multiplied by 10 raised to power minus 7 over, now I'm moving this 1, 2, 3, 634 multiplied by 10 raised to power minus 3. Okay, students, let's do a trick here. Now we are just seeing this as 4.45. So definitely 445 is going to reflect in our answer. The question is this. Now I said in this set of questions we are going to try as much as possible not to use the calculator. Okay, so if you are having 634 and you are multiplying by 4, let's say we want to multiply with the orders of 4. If you have 4 multiplying by this, what are you going to have in the first case? You have 2, 4, let's say xx. I'm not carrying out the outright multiplication. I know that 6 times 4 is 24, so I'm still going to have these 2 remaining. But here I have 1, 2, 3, 4, 5 digits. That means this is going to be like 40 to make it 5 digits like this. So if you are in line with that, I can now say this is, now look at all these options. We're having just 4.45, but of course I know that it's going to be a 2-digit answer. So I'll say it is 44.5 times this as the numerator, 10 raised to power minus 7 times, okay, not times now, not times, let's be consistent, divided by this at the denominator, 10 raised to power minus 3. And of course, if you look at this, that's going to give you 44.5 times 10 raised to power minus 7. Division will turn to minus, and then we have this minus 3. Okay, of course, minus 7 minus minus 3 is going to be minus 7 plus 3, which is going to be 4. So that means I'm having 44.5 times 10 raised to power minus 7 plus 3, which is 44.5 times 10 raised to power minus 4. But look at this, look at this decimal. Is here. Now if I'm wanting to move it just a pointer so that I will express it in standard form, that means I'm going to have 4.45. But moving it backward towards the left means I'm multiplying by 10 raised to power 1, and then I'm still having this 10 raised to power minus 4. Now 10 raised to power 1 and 10 raised to power minus 4 will become 10 raised to power 1 minus 4, which will mean that I'm having 4.45 times 10 raised to power minus 3. So looking at the options, option A is going to be the correct answer. So you can actually verify with some other method you have at your beck and call, or you can punch this directly into your calculator to see what answer you're also going to get. Okay. Oops, an option is missing here. Let's hope our right answer is going to be part of that I was there. And like I was saying, we need to start with brackets. Okay. So, and we're doing that and also converting to proper fraction. So here we have 1 over 5 multiplied by 1 whole number 2 over 3 will become 3 times 1 is 3 plus 2, 5 over 3. Okay. Then we're also adding, again, we need to carry out the operation in bracket. 5 divided by 1 whole number 2 over 3, which we have gotten to be what? 5 over 3. And of course, if you want to now operate the one in bracket, this will be 1 minus. Here we are seeing that this 5 is cancelling out this 5, so that what is remaining now will be 1 over 3 plus, in this case, it returns to 5 over 1, which is 5, multiplied by 3 over 5. So again, we are seeing that this 5 and this 5 are cutting out, and what is remaining is just 3. So we have it is 1 minus 1 over 3, this first bracket, plus this one is outrightly 3. So 1 plus 3 is 4. 4 minus 1 over 3. If you want to put a whole number as 4, okay, you can just say this is 4 over 1, then find the LCM. 3. 4 times 3 will be 12. Okay. 4 times 3 will be 12 minus 1, and that will be 11 over 3. 11 over 3, if you want to divide 11 with 3, that will be 3. 3 times 3, that is 9. So 11 minus 9, that will be 2 over 3. So it looks as if the option that we should be looking at is not here, and I think that will be 3 whole number 2 over 3. That's quite an omission, but you can check and confirm that this is indeed the solution to this question. Do we need to do this again, students? No, it's part of your do it by yourself set of questions. Okay, let's move on to some other ones. Okay, looking at this, I think what we've done so far can also help here. Again, first express the one in bracket, but even the one in bracket, you need to do this first off. Okay, let me just attempt this. I think it's combining all of the BODMAS and PEMDAS operation very good. So I will just start off by the ones that I need to start off. I won't be writing everything. First, I want to do these two. So 2 over 3 of 6 over 7 will be times 6 over 7. So I can cut 3 here 1, 3 here 2. So this is nothing but 4 over 7. So I'm having 1 plus 4 over 7. That will be 7 over 7 plus 4 over 7. And that will be 11 over 7. So I'm done with this bracket now. Okay. Then I'm having 1 plus 2 over 3 minus 3 divided by all that expression in bracket, which we have found to be 11 over 7. And here again, we need to follow BODMAS, and division comes before addition and multiplication. So we need to find this expression first. Okay. So if we are to do that, that means we are going to say this is 1 plus 2 over 3 minus 3, which is the same as 3 over 1, multiplied by 7 over 11. This is what we need to do first. So simplifying this will be 1 plus 2 over 3 minus, what is this going to give us? That's 3 times 7 is 24. 1 over 11. Okay, so this is what we now need to express out to say we have at the denominator 33 is going to be the product of these two, and then 1 will be 33 over 33 plus for 2 over 3 to express it as a baseline of 33. 3 can go in 33, 11 times 2, that will be 22, minus 11 in 33 is 3. 3 times 21 will be 63. So this is what we have, and it will give us 33 plus 22, that will be 55. 55 minus 63, that will be minus 8 over 33. So looking at the set of options that we have, B is corresponding to the answer here. And you can see how we started. First, we did the half, check. We did the bracket, check. We eventually come over to the division, check. And then we did the addition and subtraction. That is a classical example of working with BODMAS or PEMDAS, as you may choose to call it. Okay. Students, again, I think this can talk neatly under your belt. Please put your hand to it. Just notice something. When you have 0.12 raised to power 3, that means your power will need to take consideration first. And then, when you're expanding, even if you have it as 12 times 10 raised to power minus 2 raised to power 3, you still need to say this is 12 in 3 places, 12 times 12 times 12. And then this 10 raised to power minus 2, we need to become 10 raised to power minus 6 minus 2 times 3. Okay, do that and let's see what you have as your solution. Okay, I've already done the bigger thing for you. Just lay hand on it and see what you're going to come up with. Okay, this is quite a walkover too. We have 1.5x, so 1.5x is the same as 243 over 32. We have to find the value of x. Okay, 1.5x itself is 3 over 2x, is being expressed as 243 over 32. And like I said the other time, you can knock out this by multiplying with its inverse. So 2 can cut 2, 3 can cut 3. But what you do to the left hand side, you also do to the right hand side. So you also have multiply by 2 over 3, and then we can start to cut. 2 in 32 is 16, 3 here 1, 3 in 2, 43 will be 81. Okay, so x is 81 over 16. 81 over 16 ideally will be 50 number 1 over 16. But I think perhaps they are taking this as an approximate value. If I'm doing this in the exam, it's even good I just attempt it. I'm going to pick 5 because 1 over 16 is going to be quite small, quite small. So it will just be a negligible number in this particular case. And since I'm having 5, it's like they just rounded up everything to whole numbers. So I will pick option D. All right. Okay, here in this question will come to word problem, and we're told that 3 children shared a bucket of mangoes in such a way that the first child took 1 over 4 of the mango. So let's say the total mango is denoted as x. So the first child is taking 1 over 4x, and the second is taking 3 over 4 of the remainder. If the first one is taking 1 over 4x, the remaining is going to be 1 minus 1 over 4x, and that will be 3 over 4x, because 1 over 4x and 3 over 4x we add up to x. Okay, now the second child is now taking 3 over 4 of that remainder. So second child is taking 3 over 4 of that remainder, which is 3 over 4x. I hope you get that. Okay, so they are now saying that what fraction of the mangoes did the third child take. So of course after this we are still going to have another remainder, but then that remainder is what the third child is taking, which is going to be everything x, the whole of it, minus what the first child took, 1 over 4x, minus what the second child is taking and what that second child is taking, we can find as 3 over 4 of 3 over 4x will be 9 over 16x. Okay, so you're having it as minus 9x over 16. So this is what we need to just solve out to get what the remainder is going to be, which is what the third child is taking. So the third child is going to take, now we have x 1 over 4x 9 over 16x. Definitely 16 is that LCM. This will be 16 over 16 to give us x minus 1 over 4x. Now 16 divided by 4 is 4. 4 times 1 minus 4. Okay, let me just put x there. So we have 16x minus 4x, then minus 9x. So this is going to give us 16 minus 4 is 12. 12 minus 9, that's going to give us 3 over 16x. So the third child is actually taking the 3 over 16 parts of what is being shared here, which is mango. So that is option A as the solution. If you can break it down like this, definitely your work is cut out and you will get your answer as appropriate. Okay, students, I will again leave this for you. We've solved enough of this. Please lay your hands on it and let's just move on. I think we just have one question left. All right, so this is also just like that other question I just solved, and exactly in the same way. I think you can actually take, okay, there is a trick to this. They are giving us the value for the last amount. So let me just quickly run through this. 3 brothers in a business deal share the profit at the end of the contract. The first received 1/3 of the profit. So first child is taking 1 over 3 of the profit. Let me say 1 over 3p. And then if that is that, the remaining profit is going to be 1 minus 1 over 3. And that's going to be 2 over 3 of p. And then the second child, look at this, the second child is now taking 2 over 3 of the remainder. That's 2 over 3 of 2 over 3 profit. And that's going to be 4 over 9 of the original profit. Now the third child received 12,000 naira. So now we need to just find a fraction for the third child. That third child is definitely going to take the total profit minus what the first child took, which is profit over 3, minus what the second child took, which is 4 over 9p. Okay, and if you want to find this out, we have 9 as the LCM, 9p for the first child minus, now 3, 9 divided by 3 is 3. This is going to give us 3p, then minus 4p. 9 minus 3, that is 6. 6 minus 4p, that is 2p. So third child actually took 2p over 9, and that 2p over 9 we are saying is corresponding to 12,000. Okay, so if that is the case, we can just try and find the value of p. Here you can just say this is like 12,000 over 1, and we are cross multiplying. Then we are going to have p to be 9 times 12,000 over 2, and this is going to give us 2 here 1, 2 here, that will be 6,000. So p itself, the profit that was originally shared, will be 9 times 6,000, and that is going to be 54,000. I think it's quite interesting that we are ending with this word problem. So even if you get to meet your question in the exam hall and they are structuring it like this is just the way to be consistent in carrying it out. I think this is where students most likely will want to make mistake. When you get the amount that the first child will take, you need to evaluate first the remainder by saying 1, which is the whole, minus that fraction that the first child is getting. That will be 2 over 3. And then the second, which is taking 2 over 3 of the remainder, will be 2 over 3 times that remainder, which is 2 over 3 itself. And then you can get the value for the third child, evaluate your question out, and you'll be good and fine. And with that, we've come to the end of this lecture on fractions, decimals, and ratio. I want to believe that this has been of great help. Don't forget to like the video, share with your friends, subscribe to DaveTuts Academy so that we can know that our resources is actually being of help to students out there, and it will encourage us to do more. We wish you the very best, all the best in the exams, all the best in life, and on the next time, God bless you.